Hello there, and welcome back. A Ferris wheel has a diameter of 80 feet and passengers board at the bottom of the wheel from a platform 10 feet off the ground. If the wheel makes one full rotation in 2 minutes, we're going to write an equation that describes the height of a passenger after t seconds. So in order to analyze this situation, we have motion around a circle. So what we're going to do is look at the easiest points on the circle, which means at every quarter rotation, just to see what's going on. Now, the first thing to keep in mind is that we're told that it makes a full rotation every 2 minutes, but we want the height of the passenger after t seconds. So we need to make sure that those time units match up. So 2 minutes, remember, is 120 seconds. And that means that every quarter rotation will correspond to a 30-second time elapsed. So this is t equals 0, t equals 30, t equals 60, t equals 90, and 120 as well. So we're just going to look at one full rotation. Now, since the diameter is 80 feet, the radius is 40 feet. You notice that's what I have written there. So let's write the height at every one of these quarter rotations. So when we start off, we are 10 feet off the ground. So h is 10. As soon as we make a quarter rotation, our height goes up by the radius. Whoops, that was not supposed to happen there. Let's try that again. The height goes up by a radius. That means that h is equal to 50. When we go another quarter rotation, that means the height increases by another 40 units. So that's 90 feet. Then we start our descent, and that means that our height is 50. And then at 120, we're down to 10 again. So as you can see that this is a periodic function. Every 120 seconds, we're going to cycle through the same heights in the same order. Okay, so what does this look like as a sinusoid? So going over here to the graph, at t equals 0, we have a height of 10, and we know that at a time of 120 seconds, we have a height of 10 again. And then halfway between those two times, at 60, we reach our maximum height, which is 90. This may not be scaled. And then at t equals 30 and t equals 90, we have the average height, which is 50. So that's about right here and about right here. And that means our graph looks very similar to this. And of course, it's going to keep going that way. Okay, so not the prettiest sinusoid, but at least we have a good idea what it looks like. Okay, so let's take a look at the aspects of this graph. Now notice that it has a y-intercept at its lowest point, which means this is for sure an inverted cosine and has no phase shift, which means the c in the equation is 0. This is great. And that also means that the a value is negative. Okay, so looking at the particulars here, the period is 120. But we know that period is 2 pi over b, and that's equal to 120, which means that b is equal to 2 pi over 120, which is pi over 60. Okay, so we're moving right along here. The amplitude, remember, is the distance between the vertical distance between the maximum and the midline, or the minimum and the midline. Now I know in my graph it doesn't look the same, but they are the same because this is 10, this is 50, and the top is 90. So that means the amplitude is 40. I'm just going to write that as amp here. However, since this is an inverted cosine curve, this means that A is equal to negative 40. Okay, and since the midline is at 50, that means that my vertical shift is also 50. So remembering that we want the equation of a general sinusoid, so that means h of t is equal to a cosine bt minus c plus d. The equation for this Ferris wheel is negative 40 cosine pi over 60t. Remember, c was 0, and then d is 50. And that is the equation of the height off the ground that someone is after getting on the Ferris wheel.